Very important session in which we will be discussing some of the very important points and the concepts of classical mechanics. So I hope that the discussion which we will be doing today in the session will be getting clear to all of you guys. But in case if there is anybody having any doubt anywhere in the discussion we have done till now, you can surely let me know about it and we can consider those points then. Now, guys, if we are going to talk about today's session, so we will be talking about the classical mechanics major portion here in the session. So, if in case there will be anything not getting clear to you or anywhere you will find that there is any doubt you are going to have, you can surely mention it and we will be talking about those points, okay? Now, uh, before going ahead with the discussion of the topics and the concepts we will consider here, I would like to tell you uh, the about the Unacademy subscription, the important things about it, and how you can do the best preparation under the guidance of top educators. So that's what I'll be discussing here in the session right now, guys. These are just few slides about the session itself. Like we are gonna have some important topics discussion. This is something about me. This is about the community feature, which will be helping you to get the latest updates to know about the important information, and this way you can get to know about these important things on the community tab on Unacademy Learning app. This is about the let's say the iconic subscription we are gonna have on Unacademy. Okay, so if you want to take the Unacademy subscription, then how the iconic subscription can help you, what are the benefits you will get, all that has been shown here on this screen. Also, guys, even now the notes are available on the learning app, which will be helping you a lot to take your preparation to a very good level. Okay, next is the plus subscription. So what are the benefits you will get if you will take the plus subscription? All that has been shown here on the screen. Even, guys, the other important things like uh, the structured courses, the unlimited access, live test and quizzes, and daily live quizzes will be there, which will surely be helping you to do the best preparation and to take your preparation to a very good level. Okay, and whenever you are going to proceed further to take whether iconic or the plus subscription, you can use and apply the code that is Anjali Live as mentioned here on the screen. By using and by applying the code, you will be getting the discount in the total subscription amount. Also, guys, another important thing here is that the light subscription is even available, and the difference between the plus iconic and the light subscription, you can clearly have a look at that part here, and you can see that how everything will be helping you. Depending on which one you find more beneficial for you, you can take that subscription and start your preparation under the guidance of top educators. Okay, now let's go ahead with the discussion. So basically, guys, if I'm going to talk about the major portion of classical mechanics, okay, so what are the things you should try to cover up and you should not miss? That's what I'm going to talk about here in the session right now. So basically, guys, in the like in the classical mechanics, again, like we talked about in mathematical physics section. So before this video I had conducted a session, or before this session I had conducted a session on mathematical physics, where I have talked about the major portion of excuse me, mathematical physics, from where you can expect the questions to be there in your upcoming exam, how you can do that preparation, how you should start, and what are the topics based on which you can expect the questions. Like everything has been considered there too. So if you have missed that session, you can check it out. Okay, it will even be visible to you. Now, if I'm going to talk about this one for the classical mechanics, similarly, guys, as you may have found the questions we had in the 2 years ago question paper, or let's say the 5 years ago question paper, whatever it was, okay, or 10 years ago. Similarly, you will find that now if you will check out the last year question paper or your recent question paper, the questions are from the same concepts and the topics. Okay, so in this case what will happen? In this case, you need to know that the pattern of the paper, like you may have heard from so many people that now things are changing, the way we used to get the questions earlier, we are not getting them in the same way. But the thing is, it's not changing like in a way that it's completely different. but it is changing in a way how they were representing the questions earlier and how they are asking the questions now. That method, the way they were asking the questions earlier and they are asking the questions now, that can be quite different. But other than that, the topics, the concepts you have to prepare, all that is same. But also, if you are the one who is willing to make that kind of change or the difference in your uh, process of doing the preparation, or how you are doing the preparation in that part, I will tell you that what you have to take care of in that case and how you can uh, do the best preparation with this little bit change which is there. Okay, so everything we will include here. The first thing is, I would say, you have to check out the previous year question papers after you keep on covering the topics. Let's say you know what are the topics which are important. When you cover up that topic, you also have to see in the surroundings of the topic. Means, let's say this is the topic you are preparing right now, so you have to see what are the related things to this topic. Okay, what are the other related formulae, the concepts from where you can expect the questions. So don't keep yourself restricted to only this part, but also prepare the related parts to this particular topic, so that you will not be having just limited knowledge about it, but you will have the knowledge about it surrounding topics or the other related topic to the main topic. Okay, so that's how you will have the enough knowledge to work on the questions. And even let's say they asked some question where they have added some more topics, they have added some more content. Okay, means it's not just a straightforward question, so it will become easy for you to understand it. That kind of change you can make in your preparation strategy. Okay, now let's come to this part, that what are the topics you have to prepare when you're going to do the preparation for classical mechanics part. Okay, so what are these topics which you have to prepare and how you can prepare them? That's what we will talk about now. So if I'm going to talk about the classical mechanics topics you have to prepare, and from where there are great chances that you can have the questions in the exam. So the first one is the Lagrangian. Okay, and your second topic is the Hamiltonian. Like, you will find so many questions have been asked from these sections in the previous years. The next one is going to be the Poisson bracket. Another topic is the canonical transformation. Another topic is the phase space trajectory. Next one is going to be the stability analysis. Next one is the small oscillation related questions. Next one is going to be the spatial theory of relativity based questions. So these are going to be the major portion, like you have to cover up, and this is how you can just simply solve any question. Okay, so Lagrangian, Hamiltonian, Poisson bracket, canonical transformation, phase space trajectory, stability analysis, small oscillations, and spatial theory of relativity. So when you are going to prepare these ones, you will find, if you will check your previous year question papers, most of the questions have been asked from these ones. Okay, so these are most expected one, and these are very much important for all of you as well. Now, if I'm going to talk about the next one, that is what you have to prepare from this section. The major portion I'll be including here, but as I've told you, if you're the one who wants to make a change in the way you were doing the preparation earlier, or how somebody was just doing the preparation earlier with the previous year questions on the basis of what topics based questions have been asked, but if you want to make that change right now, so what you can do, you can check out the surrounding topics of that main topic as well. So right now what I will be doing, I will be taking the questions from these sections. Okay, and I will also keep on sharing some tricks, some concepts from these sections, and will tell you that what you have to do to work on these questions. Okay, if in case you will have any doubt anywhere, you can tell me. Okay, give me a second. me a second. I'm just gonna write the first question. Give me a second, guys. Okay, we are just gonna continue. Let's take the first one right now. And anywhere, if you will be having any doubt, you can tell me. So, your first question is based on the stability analysis part we will take. But it's not just the direct question, there will be some additional information we will have to relate here, and how it will be relating here, and what you have to take care of, all that we will talk about. Two particles of identical mass move in circular orbits under a central potential Vr is equal to half kr square. Let L1 and L2 be the angular momentum and R1, R2 be the radii of the orbits respectively. If L1 divided by L2 equal to 2, the value of R1 divided by R2 is options are root 2, 1 upon root 2, 2 and 1 upon 2. So I'm going to give you some time to work on it. If you can relate it with this part, that what will be the right answer and how you have to take the steps, you can just proceed further to solve it that way. Otherwise, I'm going to tell you all the steps here, and I will be telling you like how you can solve any such type of question. Okay, so everything we will be considering this way. Now let me know, like, if you are having some idea, you can even work on it and just see what is the right answer according to you. Otherwise, I'm going to talk about the steps, each and everything, what you have to observe, how you will get to know that this is what you have to do, or how you can consider that whether it will work here or not, or how to think about the steps which we can follow and we can get the answer with them. So basically in this case they have given two particles of identical mass move in circular orbits under a central potential Vr is equal to half times kr square. Let L1 and L2 be the angular momentum and R1 and R2 be the radii of the orbits, okay, and respectively. If L1 divided by L2 is equal to 2, the value of R1 divided by R2 is what? So actually they have given you the information, or in the question they are talking about circular orbits. Also they are talking about central potential. Okay, so in this case what will happen? In this case you have to consider that the circular orbits and central potential, whenever in your question it will be given, or anything about the angular momentum will be given in the question, then you will have to use the effective potential instead of just using the given potential. Now what is this effective potential? It is equal to the angular momentum square divided by 2 mr square plus given potential, that is Vr. So it is simply L square divided by 2 mr square plus half kr square. If in this case we are going to talk about the next thing, that's going to be that what will be the next step we will take, because they are asking us to find some relation between L and R. How we can get to know about it? Because they have given you L1 and L2 values and they are asking you to find the ratio of R1 and R2. So what you can do, we will firstly take the step which we take to find the equilibrium point, like delta V effective divided by delta R equated with 0. So when you are going to do this, so it is going to give you negative L square divided by mr cube. Okay, and the other thing you will have here is the plus kr square, that is equal to 0. So in this case what will happen? You are just going to get this. Okay, just check it out. Are these values you are going to get or something else when you are just going to consider the dependency of L on R? Look at all the steps you have taken till now. Oh, you have differentiated it. It should be just kr, right? Not the kr square. So 2kr, 2 cancelled out. You are just going to have kr there. So negative L square is equal to m k r to the power 4 with the negative sign. M and k are constant, so L square is proportional to r to the power 4 and L is proportional to r square, right? So L1 upon L2 will be equal to R1 square upon R2 square, right? So L1 upon L2 is given to you, which is 2. So 2 is equal to R1 divided by R2 square. So that will give you R1 divided by R2 is nothing but root 2. Hence your option A is the correct one. This is how you can simply get it. But tell me if in case there is anybody having any doubt in this part, we can talk about that. So what you learned in this question, anytime if your question is related to circular orbit, central potential or angular momentum, you can't use the given potential directly. You have to use the effective potential. This is the effective potential formula where L is the angular momentum and V is the given potential, R is just the distance, M is the mass. We have put the given potential value here, and this is how we just found out the delta V effective divided by delta R equal to 0. Why we are doing so? To get the equilibrium points. Once you are going to consider this part, in this case, this is how you are just gonna get it. Okay, so L is proportional to R square. Now what will happen? L1 divided by L2 you will be getting as R1 square divided by R2 square. So L1 divided by L2 was given as 2. You are just gonna put that value. R1 divided by R2 will be root 2 this way because the square is given on the other side. This is how everything will work, and this is how you can simply solve any such type of question. Now I'm going to give you the next one, but if in case anywhere you will be having any doubt, you can surely tell me about it and we will try to consider those points. Okay guys, let me just take the next slide to show you the next question. If in case there will be any doubt anybody will have, surely tell me. We will try to discuss that too. While I can't see anybody's comment right now. magnitude of vector r, magnitude of vector p, unit vector r dot unit vector p, 3, and the next one is 1. Try it now and let me know as you will get it done. If in case there will be any doubt anybody will have, we will be talking about it. When you are going to try to work on this one, I would like to tell you something about the Poisson bracket till that point of time. So guys, how the Poisson bracket works, actually, let's say there are two functions you are having a and b, which are the functions of x and y both. Okay, means x and y is there, so px and py can also be there, right? So in this case, what will happen, you will take it to be delta a over delta x. The first one differentiation with respect to position coordinate, and the second one with respect to momentum. Negative sign, the first one with respect to momentum and second one with respect to position. Plus sign in between, first one with respect to again position, but that will be for y. So similarly, how we have written for x, we will write for y too. Second one with respect to momentum, first one with respect to momentum, and second one with respect to position. This is how you will consider it. Now in this case, what will happen, you can see you are having r and p vectors and their magnitudes mentioned there at places of a and b. You have to see, is this just the x and y you will have there, or x, y and z all? Similarly, you will write one more bracket term for z if all the three you want. If only one will be present, just write the x1. If only y is present, just write the y1. If all x, y, z are present, write for all of them. So depending on how many coordinates are involved there, you have to write the expressions for all of them this way. Now tell me if there is anybody having any doubt, we can talk about it. Otherwise, I'm going to just continue the discussion and we'll be talking about this part, that what steps you have to take. So basically guys, magnitude of vector r is what? It is square root x square plus y square plus z square. Okay, and magnitude of vector p is what? That's going to be square root of px square plus py square plus pz square. Now what will happen in this case, if it is a, it is b, so all the three terms you just have to write this way. Done. This is how you will consider. Now next thing is, once you're gonna go ahead with these steps, you have to be very careful about the calculation, because it is within the square root and then x is within that. So that is nx n minus 1. You are calling it to be complete capital X. So nx n minus 1 upon 2 capital X. Okay, n minus 1 means half minus 1. Then the inner part differentiation once again, that is 2x. So that's going to be square root of this value within, like the term which is within x square plus y square plus z square to the power minus half and 2x. 2 you can cancel out. Same way for y, same way for z differentiation and px, py, pz. You will just be writing all these terms. Once you are going to work on this part, your final expression which you will have is going to be x px. In the denominator, you will have a square root of all the similar values we had already. So this is what you will get then. Y py divided by magnitude of r, magnitude of p vector, and the next you will have is z pz, and next you are going to have is magnitude of r, magnitude of p vector, right? So this is what, this is going to be simply, if you will say vector r is going to be xi cap plus yj cap plus zk cap, and vector p is what? It is going to be pxi cap plus pyj cap plus pzk cap. So r dot p will be what? That's going to be xpx plus ypy plus zpz. Okay, and this is going to be nothing but r dot p you will have divided by magnitude of vector r and magnitude of vector p. So what it is unit vector r dot unit vector p you will have there. That's how you're just gonna get it. Now let me know if there is something not clear to you or somewhere there is any doubt you're gonna have. We can talk about it. But if everything is clear, then that's great. I'll be giving you the next question if it is clear. Okay. If there is any doubt still anybody's gonna have, just mention it, guys. We can consider that part too. The value of dl by dt is, options are so in this case, they have given you the Hamiltonian of a simple pendulum consisting of a mass m attached to a massless spring of length L is this. That is H is equal to kinetic energy plus potential energy. So kinetic energy form is p square upon 2 ml square plus, that's basically 2m, p square upon 2m, right? So at place of m you are having is ml square plus mgh. At place of h you are having is L into 1 minus cos theta. So what will happen in this case, it's going to be half mv square is going to be there in your Lagrangian. So half ml square, and velocity square means theta dot square plus the negative sign, the potential energy. So it's going to be mgl 1 minus cos theta, right? One more thing, that when you will work on the total time derivative part, so what will happen now, how I have written the Lagrangian, I would like to repeat it. So I have compared the kinetic energy term of Hamiltonian, which is p square upon 2m, and what is that, that's going to be, the m is ml square there. So half mv square, so ml square theta dot square, negative sign the mgh, which is the mgl 1 minus cos theta. So this is how we directly mentioned it. But what is the dl by dt? It is the Poisson bracket of L, the function for which we want to find the total time derivative with the Hamiltonian, and plus delta L divided by delta t. Okay, now the next thing. If we are going to consider the next thing here, the L is something we are already having, the H is something we have to consider from here. So in this case, you will have to find the, and you know L is not dependent on time, so your Poisson bracket of Lagrangian with respect to t will be 0, right? So this is how you can just directly take it equal to 0. So in this case, what will happen next? You are just going to have the delta, the Poisson bracket of L with H remaining. So in this case, what you will be doing, let me just show you all the steps here. So Poisson bracket of L with H. Which is simply delta L upon delta theta, delta H upon delta P theta, minus delta L upon delta P theta, and delta H upon delta theta. This is what you will have, right? But you can see in the L part, you don't have the theta present there, or the P theta present there, not the theta, P theta present there. So what you will do in this case, you have to use the formula, that is the P theta dot is equal to, or P theta, okay, use this one. The first Hamilton's equation of motion, which is theta dot is equal to delta H upon delta P theta. When you are going to consider it, you will get P theta divided by ml square is theta dot. So what you will get, P theta is equal to what? Ml square theta dot. Okay, and theta dot is equal to what? P theta upon ml square. You can just put the theta dot value here, right? And you will be getting the Lagrangian in terms of P theta as well. And once you get that, now it's easy for you to do the differentiation of Lagrangian with respect to P theta. In the Lagrangian, you already have theta. In Hamiltonian, you have P theta. In Hamiltonian, you have theta too. So you just have to differentiate these values. Just put these values here at these places, and you are going to get your final answer to be negative mgl. Okay, the final answer will be negative 2g by L P theta sine theta. This is what you will get. I hope it's gonna get clear to everyone, guys, but in case if there is anybody who's not getting it, you can tell me, or just take your calculation if still you don't get it. But remember, you have to find the theta dot value in terms of P theta and then just put it here, and this is how you can solve this type of questions. If in case there is anybody having any doubt, just let me know and we can talk about it. But if everything is clear, then that's great. Now we are going to keep it this much right now in this session, guys, and as I've told you what are the benefits you will get if you will be taking the Iconic subscription, all that has been shown here on the screen. What are the benefits you will get if you will be taking the Plus subscription? All that has been shown here on the screen. In case of Light subscription, and the difference between the Plus, Iconic and Light subscription has been shown here too. So depending on which one you find more beneficial for you and which one you want to take, you can go ahead to take that subscription and start your preparation under the guidance of top educators today. Take your preparation to the next level, because in upcoming days even so many new courses will be starting on Unacademy. So if you don't want to miss all these important courses, then you can take the subscription and start your preparation under the guidance of top educators today. Let's keep it this much right now in the session, guys. And thank you so much everyone for joining this session and for attending it till the end. I hope each and everything is clear. And guys, all these courses we are gonna have on Unacademy will be helping you a lot to take your preparation to a very good level, as well as to know about what you can expect in the exam, what are the topics which are most important, and from where there are great chances to have the questions in the exam. Like everything you will be able to consider and get. Okay, so this is how these things are just gonna work. But in case if still you have any question and you want to ask it, so you can tell me that whatever is the doubt and we can talk about it. Also guys, we will be having more sessions here on Unacademy Live CSIR UGC Net, where we will talk about the most important points and the topics, concepts, and the important subjects too. Also, whenever you will proceed further to take the Unacademy Plus or Iconic, any of these subscriptions, use and apply, or any even the Light subscription or any subscription you will take, you can use and apply the code Anjali A Live to get the discount in the total Unacademy subscription amount. This is how, guys, you will be able to save more. Also, if there is any of your friends who also want to do the best preparation, want to get the guidance by the top educators, then you can let them know about it too. Another thing is, we are gonna have so many courses going on Unacademy by the top educators. After taking the subscription, you will be able to join all these important courses. Okay, let's keep it this much right now. Thank you so much everyone for joining the session and for attending it till the end.